Hi, again. It's me again. Come in, don't be shy. So yeah, new day, new hat, new slides, everything is kind of back where it started. This time I've got the collaborator hat on me, which might mean different things depending on how you look at it. And this time, I mean, yesterday in the morning I had 10 minutes of slides. Yesterday in the afternoon I have, no, 20 minutes in the morning, 10 minutes in the afternoon, so kind of you can interpolate from that. The topic is collaboration, many different kinds of collaboration. The key point really is that there's something in the application that updates live in real time immediately when something interesting happens, and then through that users can collaborate with each other. And I actually cheated, I have one slide still, just to show that there's many different kinds of collaboration use cases. There's first row, there's actually not real collaboration, you are just collaborating with the server. Doing something, the first one example is starting some kind of slow running thing on the server, and then you collaborate with it to know when it's done. So you see the progress there, and then eventually you get to know that, okay, now this thing that you started is done. Next thing is also collaboration with some external systems, so not kind of human-to-human collaboration. Different kind of monitoring things, server utilization dashboards, stock tickers, those kinds of things. So again, something happens somewhere, and immediately when something changes, you get an update in your UI. Then we get to the actual kind of human collaboration. We got presence, just seeing who else is present in the same part of the application, maybe editing the same entity or depending on your use case. Then we got the opposite, which is locking, to make sure that you are the only one doing some specific thing to avoid conflicts, avoid stepping on each other's toes, and so on. We got notifications, which is all about knowing when something has happened and getting actually some kind of display on the screen about that. We got messaging, chatting, talking with each other directly through the application. That might be useful sometimes because, I mean, jumping back and forth to Slack when you're trying to do something in your application is not always so useful. And then the final use case for collaboration is to actually edit things together. So depending on the use case, you might have some report that you're working on or something like that, and then many users can preferably at the same time work on that. One kind of similar example is just, for instance, Google Docs, where you can have multiple persons editing the same document together. What's common with all these cases is that, well, they need real-time updates. And the thing I want to bring to you today is the way of doing these is by thinking of it as sharing UI state between these users that work together. Because when you think of it that way, then things just get simpler compared to more kind of low-level approaches. Because behind the scenes, there's always a WebSocket to actually push out those changes. And that kind of leads you to thinking in terms of kind of, now we're sending messages, now we're sending events or something like that. But if you use that level of abstraction when you plan your UI implementation, then you will probably cause a mess for yourself. But if you instead think of it as, hey, we have these pieces of the UI state that we want to share with these other users under these circumstances, with that kind of mindset, things get much easier. To start with, after this very brief intro, let's have a short moment to ask, what about you? So please bring out your mobile phone, or you can also use your laptop. Just go to v-herd.eu/poll. And then through that, I will actually be able to see what you think about these kinds of things. So let's see, we got lower right corner, live updating there, how many persons we got here, 40, 41, 42. Yeah, I would guess We are quite close to having the full room since half of you are in the other room also. Yeah, now we're stabilized there. So let's get started. First question. Let's make it a little bit bigger here. Actually, we can't do that because then you won't see everything. So how do you build UIs? There's Flow, there's Hilla, of course, because we're in a Vaadin conference. Maybe you're using one of the top 3 most popular single-page application frameworks, React, Angular, Vue. Then there's, of course, lots of other client-side solutions. The most popular but not so obvious one is jQuery, if anyone uses that. So then you can vote for multiple things here also. Then we've got server-side HTML. You can use PHP. You can use JSF. You can use just very raw Spring MVC or Jakarta MVC. Desktop native mobile with a couple there. We've got some people who have problem deciding. Are you an Angular user or not? Now is the time to choose. Damn you nerds. So, next question. Have you already built UIs with real-time updates? So, maybe some of you do it all the time. Some of you maybe a little bit sometimes. Some of you might be planning to do it. Some of you aren't doing it and not planning to do it. And then I wonder why you're sitting here, but that's your problem, not mine. So it seems like we got roughly the right amount of answers, lots of fluctuation, but let's, now it's almost stabilized. Excellent. So, yeah, most of you have tried, I see, but it's not really a habit of yours. And then there's also some hopefuls and some real experts in the room. Last question. If you don't do it, then why not? What's your excuse? So is it because, well, you actually already do it? Is it because in your domain there's no use cases where you think it would be a good thing to do? Maybe you think it would be great, but your customer or product owner doesn't think that it's a good thing to do or important thing to do. Maybe you would want to do it, but you're afraid of the UI design effort because you actually need to think a little bit about how you do those UIs to make them work well. Or maybe it's just kind of too difficult to implement it. Zoom in, yeah, that's true. Now we can fit more options on the screen, so there you can see. So it seems like it's quite evenly distributed, except the UI design. That's not a worry for you because, well, you use Vaadin, so UI design comes automatically. Okay. Then, I mean, what we have here is an example of collaboration. Every one of you are now together contributing to giving the right answer to this question, or the right statistical answer to this question. So what we're going to do next is actually, let's build this application again. And not to make it kind of more interesting, let's build it 3 times. First in Flow, then in Hilla, with what we have in Vaadin today, and then a 3rd time in Hilla with the new upcoming full stack signals that I also mentioned yesterday. So let's remove this destruction. Actually, let's take it back because I want to have that window. That's not where I pressed. So localhost 8080/flow. Yes, so this is, let's zoom in a couple of steps there also. This is kind of the same application. I got already, I got some really awesome CSS from a designer just to showcase that. Here in the flow code, I just changed the class name and then redeploy, and then it's really ugly. But then with this, just a little bit of CSS, we got this really beautiful thing. But the point really here is, this application is, it's not real-time updating. So if I now in one of the browser windows, I vote for Flow, then nothing changes in the bottom one. And that's what we're going to fix. But at the same time, these actually, they use the same underlying data service. So if I save and I reload, because now this says 6 and this says 5, if I reload, then they both get to 5. And the implementation here, we got this vote service, which actually keeps track of the votes. We inject that in the constructor. We set some class names, yes. Then we iterate through the different options that the vote service said that we have available. For each of them, we can create a poll option component that's implemented down here. So it's just a vertical layout with a checkbox and then one div that is the bar that has some CSS to adjust the size. When the user interacts with the checkbox, this callback is run. It tells to the service that either increment or decrement the count for that option by 1. And then once that is done, we fetch the new state from the service and update all the sizes of the bars based on that. And then, of course, in the very beginning, we need to remember to also do an initial update. And now to make this real-time updatable, actually, let's look at the service first, because that's where we need to start. The service is also very simple. It's a Spring service. It's also browser callable and anonymous allowed for the Hilla example. We just have a map with the count for each of those options. We initialize with some values just to see something on the screen here in the example. We got the update my count method. It just finds the option in the map and increments it by the delta, and then also get the state. It just creates a copy because multi-threading we need to take care of not kind of corrupting any state. So now to make this update live, we need some way of subscribing to changes from this service. One really great way of doing it, it's great because that's the way I'm going to use, is something called a flux. So this is from the project Reactor, which is built by the Spring guys, but it's not tightly tied to Spring, so you can use it without Spring also. And what Reactor has is this type called a flux, which is an asynchronous stream of multiple values, and then you can subscribe to that, and whenever there's a new value, everyone who is subscribed to that also gets a notification about that update. To create a flux, we need to create, or in many cases, you get a flux from somewhere else. There's some third-party API or something that already has flux support, and then you just get it from there. But you can also easily create your own flux. One way of doing that, which is very flexible and exactly what we need, is by creating first a sync, which is something where I can put in those updates, and then you can create a flux that kind of receives on the other end what is put into that sync. To create a sync, we can use this factor class here, and then we need to choose what kind of sync. Actually, let's make it slightly bigger. Yeah. What kind of sync? In this case, we want a sync that can receive multiple updates. There's also cases where you just submit one update. But here we got a sync.many. And then again, we need to choose what kind of sync. And for this kind of use case, a replay sync is really awesome to use. Oops. Because what a replay sync does is that whenever someone subscribes, there's a new subscriber, then they will also receive a couple of the latest updates. So you don't start from scratch, but immediately when you subscribe, you get up to speed, and that's very convenient with the way I'm going to use it. So actually, I'm going to create one with the limit of 1, which means that this sync always remembers the latest update, and then when a client subscribes, it will immediately receive that update. Let's create this into an instance field. And let's make it so that the type of the values that we pass into the sync and also get out of the flux is this whole state. So this is what I'm talking about. We are now synchronizing the UI state. In this simple case, I'm just pushing out the whole new state. It's just a map with 3 values, so it's not terrible overhead to send 3 updates, even though only one of the values changed. You might want to optimize things, but to keep it simple, I'm not doing that. And then finally, the last thing we need to do is, actually we need to do 2 more things. First, we need to create a method for actually getting that sync or getting flux. So let's get naming again, like we learned from Josh and Marcus yesterday, is very important. Let's call this flux. Import it, and then just return sync dot no, it's not called sync, it's called limit. That's a stupid name. Well, let's keep it like that now. Limit.asFlux. The last thing we need to take care of here, no, the second last thing. No, it's the last thing. When we update the count, we also need to publish the latest value to that sync. So what we do is we take the stupidly named sync and we try to emit. Because of technicalities, some kinds of syncs might not always accept values if nobody subscribes to them and so on. This kind of sync always accepts values, so that's not a worry. But in some cases, that's not the case. So that's why it says try emit, and it might fail in some cases. Now we're almost done in this service, but now there's just one more thing. Because when we now run this update count method, by default what happens is that all subscribers are also notified on the same thread, which means that if we have 1,000 subscribers, then we need to wait until the message has been delivered to all 1,000 of them before this update count method returns, and that's not always optimal. If you want to be doing things in a fancy and good way, you configure the flux to do this using some complicated APIs. I'm going to do the simple way of just starting a new virtual thread for emitting this value, and then I don't need to worry anymore. So let's just move this inside here, and now we are ready to go. So now we have this service that you can subscribe to updates. Whenever we update the count of any of the votes, we also emit a value to the sync, and then anyone who is subscribed to that flux will get those updates. So now we can go back to the Java class here. One thing to notice still with this service, I mean, this is a service, which basically means it's a singleton. We got one instance of this. And now here, when every view, every kind of browser that is open to this page, to this URL, it has its own instance of the component, which means that if we just subscribe to that sync or to the flux, that will have a back reference to the UI instance indirectly, which means that we will leak memory if we not clean things up, and that's not good. So we actually need to take care of kind of subscribing when this component is attached, and then when it's detached, we unsubscribe so that we don't leave any references behind us. So to do that, we override the onAttach method, and in that, always remember to leave the super call because it might do something important. What we're going to do here is, actually what we're not going to do, but I'm still going to show it because the too popular way but not completely right way is to here do, we need to lock the session for this UI because the whole component tree inflow is designed to only be accessed from one thread at a time. There's every now and then there's a question that can't you just make it thread safe? And the answer is yes, we could make it thread safe, but it would be terrible for you to use it in that case, and we don't want to make it terrible to use. So that means that instead we say that always remember to lock the session, otherwise you will have problems. This also leads to the good thing that then we, from the framework point of view, we also know when you are done updating things. So when the lock is released, then we know that this is a good moment to push out updates to the client. So in that way, we can kind of get two benefits from that. The way to lock things is to get the UI instance, and then we actually need to get it out of the optional. And then there's this access method that you might have seen or might even be using. There's one serious bug here, even though this doesn't even compile yet. And that's, actually, we should subscribe first, sorry. So we got the vote service, and then we get the flux, and then we subscribe with a consumer. And here we get the new state. And now we are actually in the place where we should update the UI. Yeah. So here now, when this is called, we want to update this UI to actually use the new state that we received. And here, you should never do like I just showed you. You shouldn't call get UI in a callback that is run from a background thread, because getUI accesses part of the component tree, and we just said that this isn't thread safe. The tricky thing is that it will work in most cases. But then once in 1,000, once in a million, eventually it will explode, and you will have very interesting stack traces, and you will have no idea what goes on. So instead, just get into the habit of never calling getUI on a background thread. Instead, one awesome way of subscribing in the onAttach method is that the attach event also has a reference to the UI. So we can just do access event.getUI, and that's thread safe. That's completely fine to do. So that's the way of actually updating from a callback. The next thing, though, is what we do here typically is that we have a callback, and here now inside this callback, we can actually update the UI, say to all the components what they should do, and so on. But this tends to be quite ugly, because here we have a callback inside a callback, and that's just ugly, yes. So instead, there's this alternative way also of updating things, and it's called UI.accessLater. So what this does is that it takes a consumer and it returns a consumer. It takes a consumer that will be run with the UI locked for you, so you can do all the UI updating there, and then it returns a consumer that is safe to call from the background thread. So that means that we can actually just move this out of the subscription. We do this once to create, actually we can even move it here. We run this just once to create a callback that we use for subscribing. So we subscribe with this, and then here in accessLater, since the Flux gives us now the updated UI state, and we do have this update bars method that receives the UI state, so we can just pass it there directly. So we just do this : update bars, and there we go. This also takes a detach handler, but we don't need to care about that. So in this way, what we're doing is we just take that updated UI state that we received from the Flux, and we just wrap that callback to make it thread safe, and just update the UI using the exact same state management thing that we already had from before also. So in this way, making it, I mean, I was talking very much while doing this, but in practice, when you have things structured in this way, when you think of it as sharing UI state, it's usually just 1 or 2 lines of code extra to make it also update the UI state from this background thread. One thing more that we need to do, like I said, we don't want to have any memory leaks. So when we subscribe, we actually also get something called a disposable. So that's a way of cleaning up the subscription later. We need to do that when detaching, so we can here add detach listener. We get some kind of event there. And then we need to do 2 things here. The first thing is obvious. We need to take this disposable and say to it that now we no longer want to get any updates. But then we also, it's not really needed in this case, but a good habit. In case this component can be reattached again after it has been detached, we would now be adding another detach listener. And, well, 2 listeners is not bad, but if it happens 100 times, then you might have a memory leak again. So we can actually here also just tell the event that let's remove this listener also. Now we should have everything we need to be able to actually live update this. And since I'm using hotswap here, it's probably already working. So now when I click vote for anything, then the other UI also updates, and naturally it works for both the UIs. Awesome. Let's take Hilla. So now here in the bottom, I got the same thing implemented in Hilla. The only difference you see is that it actually has a Hilla logo there, because I was confusing myself about what I'm looking at. This uses the same service as the Flow version, which means that now when I vote from the Hilla UI, The service will update, the Flux will be updated, which means that the Flow UI also updated automatically. But it doesn't work the other way around. We haven't implemented it yet. So when I vote on the Flow UI, the Hilla UI doesn't react yet. The cool thing in Hilla is that it has built-in support for returning fluxes from Hilla services, which means that we can just, from client-side code, subscribe to this Flux and immediately get the same updates. So if we open the Hilla view, it's kind of the same structure. We could start from state management, yes. So here we have 3 different signals, one for each of the 3 options. Just initialize them with some dummy value. Then we got something called use effect, which in React is kind of a detach listener. It's got a weird name because it can do many other things also. But you can use it as a attach and detach listener by just passing an empty dependencies array to it. Then it will be run only once. So when attaching, we now call the service, fetch this, or request the state from it, and then we pass that to the update state method, and that then updates these signals. These are still, I mean, I have talked about full stack signals. These are not full stack signals. These are just regular signals that are scoped to this specific view instance. When rendering, kind of the same thing. We got a vertical layout, we got the heading, then we loop over all the options, create this checkbox, and so on. In this loop here, we have this checked change listener that does quite the same that the Flow version did. First, it sends to the service that let's update the count, and then it also immediately updates the signal value so that immediately when you click, you get to see that it's been registered. You don't need to wait for a round trip to have it confirmed. And then doing the opposite in the if it's unchecked instead. So now to make this use our Flux instead, we don't need to do many things. Here in the use effect, so when we attach things, we can, instead of doing get state, we can do get the Flux, or run the method that returns a Flux. When I changed the code a while ago, Hilla was also regenerating this TypeScript to be able to do that. Here on this Flux, there's immediately an onNext method, which is called whenever the try emit next is called from the server. So here we again receive the new state, and since that's exactly the same format of the state that we take in this existing update state method, so we can just pass it there. Last thing we need to do here also is to not have any memory leaks. So, oops. So here also, this onNext method returns a subscription, and then we can here, these effects work so that you can return something from them, and that's a callback that will be run when detaching. So here we can do sub.cancel. And in this way, we now have everything set up for the Hilla part to also be multiplayer. So now the Flow and the Hilla part should be able to speak with each other. So now if I vote in the Flow part, we immediately see that the Hilla part also reacts to that, and hopefully I haven't broken anything. Yeah, no, this part also works as expected. So what we saw here also, exactly the same thing. I will keep repeating it because I think it's very important. It took me 10 years to realize this. You get it for free now. Think of these UI updates as sharing UI state. In this case, the state that we're sharing is those 3 numbers. How many has voted for Flow, how many for Hilla, and how many for React. And then just by thinking of it as sharing that data between all the users with this view open, in that way, the collaboration gets really natural from a kind of psychological point of view, how you think about things. And since this insight, I mean, yes, it took 10 years to realize it, but this is so fundamental that I started thinking that maybe we should make this way of doing things a core framework feature. And that's where you get to the full stack signals. So the whole point of a full stack signal is that you don't need to have any fluxes, you don't need to kind of push out those or try to emit changes or anything. Instead, the framework itself takes care of synchronizing the UI state that you ask it to synchronize between users. What this means is we need more things in the service. We need a way for the Hilla UI to directly subscribe to a signal, or 3 signals in this case. I'm going to show this only in Hilla because we haven't implemented it for Flow yet. That's somewhere on the roadmap, but we have some way to go before we get there. So what we can do here is create yet another service method. This case, it returns a number signal. So that's a signal containing a single number. Let's give it a really good name like signal. And we pass the name of the thing we want to have there. And then we need to keep track of those signals. So let's just create a map for that. Private, thank you. Map from string to number signal. That's signals. And let's make it a concurrent hash map, so we don't need to care about any conflicts here. And then now in this signal method, we can just say signals.compute if absent. So get it if it's already there, otherwise we create it. We get some callback here to create a new one if it didn't exist. And here we can just return a new number signal. And we need to return that thing also. I'm not now also setting things up to synchronize with these other kind of the counts that we had for the initial implementations. We're still missing a couple of APIs to be able to do that in a sensible way. So for now, in 24.5, you can just manipulate the values from the client, whereas the server is the one that controls who has access to which signal. In the client-side implementation here, we can throw away code. That's always a good thing. We don't need this update state. We don't need this attached listener. I'm going to move the state outside of the component, because when everything you have in a React render function is run again when that component is re-rendered, and that's quite often in some cases. In this case, we don't want to create a new signal instance on the client every time, so instead we move this out. The good thing with the signals is that they automatically detect if any UI component actually uses them. If nobody uses them, then it's just a couple of bytes in memory, and then when it's actually used in some UI component, then the signal actually sets up a subscription to the server-side value. So in that way, you don't need to care about any cleanup or anything like that, which is also why we can actually use these here outside of the render function without leaking memory. So we got the vote service dot signal, and then here we get a signal named flow. I mean, it doesn't really matter what we have here as long as we have unique strings for all of the 3 cases. Oops, Control-C, and then we got this one, and this was the Hilla one, and this is the React one. And yeah, this should work. Let's also make the other browser use the same data. So now we start at 0 because, like I said, we don't put the initial values there now. But now also when I vote here, the other one is immediately updated, which is exactly what we wanted. There's still one bug here. It's quite subtle. I don't think you even noticed it. Actually, we can simplify more. We can remove these calls also. Because what also happens here is that whenever I, on the client, update the signal value, that's also synchronized with the server. Because again, I just update the state, and the state is shared with everyone else. But that's also where we have the bug. Because let's make it really obvious. This ++ here is actually that the signal value is signal value +1. And that means that if you have multiple users at the same time voting for the same thing, let's say that we have got 2 users at this point voting for flow. Because of network latencies, it might very well happen that in both cases they reach this line of code, read that the value is 2, add 1 to it, that's 3, and then both of them assign a 3 as the new signal value here. And we would expect 2 votes plus 2 votes to be 4 votes, and that's how democracy works also, but that's not how things happen to work here because of this, this race condition that we can have. So whenever we share any state in this way, instead of overwriting the value, if we want to protect against these kinds of conflicts, we need to do some kind of incremental operation. Luckily, we got that implemented, so I'm just going to tell React that we actually have, or TypeScript that we actually have number signals here now, not the generic signals we had previously, because this number signal class, it has an increment by method. So now if we say increment by 1 here, and then we said the weird thing increment by -1, now what actually happens in the same case with 2 votes for flow and two users at the same time also voting for flow, each of those clients, they will not compute a new value and send it to the server, but instead they will send to the server add 1 to it, and then the other one also sends add 1 to it. So then the server receives 2 different add 1 operations, and in that way everyone agrees that we had 2, and then 2 times we added 1, so then we end up at 4, and then everything works as it should. I think that's kind of the functionality that I wanted to show. So if there's any questions at this point, I would be very happy to take them, and then once we start running out of time, I will wrap up, and then we can go to the next adventure. Yes? I don't, okay, yeah, we'll have a microphone coming. Your call is very important. Please hold.
Hello? Yeah.
Hello.
Yeah, I have 2 questions. The first question is, why did you use increment by -1? Don't you have a decrement by?
I don't need it because it,
Okay.
I mean, now we're getting into the depths of framework design. We want to avoid bloating the APIs. We don't want to have many ways of doing the same thing. So that's why, I mean, yes, it's a little bit weird to say increment by -1, but technically, I mean, it's the same as add 1, but because we can have lists also here, and when you have a list and do an add operation, it's completely different than arithmetic add operation, so that's why we wanted to have a separate name for it, and then we ended up with increment by.
Yeah, sure. Okay, I get that. And the second question is, can the signals be typed in this component as well? Sorry, the key in the signal. Could you just scroll up a bit?
Yep.
And then, yeah, this one, can this be kind of typed so you don't get typos or stuff like that?
Yes, that's also possible. I mean, first thing is that this is just a Hilla service call like any other. So I could pass an object here. I could define any type. I could define a, on the Java side, instead of saying that this takes a string, I could say that this takes an enum, and then there would be a generated TypeScript enum for that also, and then TypeScript would require me to pass a valid enum from that type.
Okay, great. Thank you.
Yep. Are there more questions? Yep. And the mic bearer. Okay, well, you can be the mic bearer. Thank you.
Thank you. Is there a way to abort the incrementation if there already happened incrementation when you send the implementation? So is there a race condition that you abort one incrementation or do something else with the new updated state? So you send your incrementation and you have your state, and
then I receive an update and change my mind?
Yes.
Yes, no, maybe is the answer. Because behind the scenes, what we're doing here is that we have an event log of all the operations that have happened. And like with all event logs, if you start to remove things that have already been added to that kind of log, then you have lots of interesting problems. So there should be a way of maybe canceling an operation, and that might or might not succeed depending on if the operation actually was already submitted to the event log. So it becomes a little bit complicated there. But also, I mean, in most cases, you can detect that in your UI logic, and then if needed, you just send a kind of compensating increment by -1 or something like that. Because again, I mean, one thing that is quite fundamental here also is that we are working on sharing UI state. This isn't the kind of data you store directly in the database. This isn't kind of authoritative business data. This is just a temporary kind of collaboration state, and then okay, in this use case, this is the final data. But if you would, for instance, be editing a form together, then you usually have kind of a submit button when everyone agrees that now we have made all the edits that are needed, and then you click submit, and then the actual values are actually stored in the database. So in that way, it doesn't matter too much if you have some data races there also, as long as they are logical to the user. Yeah.
I get that this is an optimization to make Hilla work better with the services, this full stack signal stuff. Is there also an intention to make this available in Flow? For instance, if you have a checkbox, you have to call set checked, and then before you do that, you have to make sure to first get into the UI session, etc. Is there a plan to make the checked state a full stack signal that you can access and simply set?
Yes. So like I showed in the keynote yesterday, using signals for state management also in Flow, it will make it easier to do these real-time updates because you don't need to care about the locking, but it will also make overall Flow nicer to use because you avoid those cases where you have multiple dependencies on something, and then whenever one of them changes, you need to take everything into account. So we definitely plan to make it so that you can use regular signals for UI state management in Flow, and then also through that, just kind of depending on from where that signal instance comes, with whom it's shared, you also get collaboration for free. The scary thing is that we will need to update all component APIs throughout Flow. The good thing is that we can still keep the current ways around and also add like a set. I mean, now you have a set checked method in the checkbox that takes a Boolean. We could also add one that takes a signal containing a Boolean. And then that would not only assign the value once, but it would actually set up a subscription for that signal, and also even make it so that when the user interacts with the checkbox, that also updates the signal. Any other questions? Yes, one in the back there.
I would actually like to use it with the message list component, and I think therefore I would need something like a list signal or something. Is there other plans for such a signal structure?
Yeah, so what I showed here is a number signal. We also have a value signal which contains kind of any value, any kind of value. But to be able to do incremental updates, if you have a list of data, then you need something more. That's exactly, we call it a list signal. The good thing is that you should just upgrade to 24.6 alpha, whatever is the latest, and there we have a list signal. So it's not in 24.5, but it is in 24.6. Yeah, one thing I forgot to mention, yes, is that this whole signal thing also, it's a feature flag, so I have here also enabled that feature flag full stack signals for Hilla to be able to use this, because this is still work in progress, so we'll probably end up adjusting some things. We don't know what yet, but we'll see. I think Oh yeah, that was my second slide. Forgot to show it. Hope you didn't lose track of where we were. So now I think it's time to recap. The very essential thing I want you all to remember, 10 years of learning goes into this sentence. Think of collaboration as sharing UI state. And then we saw how to do it in Flow using UI access later with the detached listener. We saw how to use it in Hilla with on effect to get attach events and subscribing to a Flux. And we saw how it can be made even simpler in the future using full stack signals. So thank you and have a great rest of the day.